Okay, so we're going to go through the lesson 13A homework, transformation practice. Just before we start, I want to make sure that we are on the same page, that going clockwise means we're going this way, okay? And going counterclockwise actually means we're going that way. I know it sounds a little bit ridiculous, or seems a little bit ridiculous to start there, but it is a good thing for us to be on the same page as we start. Okay. So number 1 says to rotate the figure below 90 degrees clockwise. Well, when we rotate something 90 degrees clockwise, our coordinate notation is x or y comma negative x, and what that means is we transform all of these pieces, all of these points. We're going to write the y first and change the sign of the x. Write the y first, change the sign of the x. Write the y first, change the sign of the x. Write the y first, change the sign of the x. And then we're going to go ahead and plot all of those. So we're going to be at, actually let me highlight in the x and the y axis, make it a little bit easier to count. Okay. So I have, let's see, our transformed y, we're going to be at 3, 1, 2, 3, 4. Okay, so there's our transformed y. Our transformed k should be right below that. Okay, transformed b should be at 0, negative 5. And u is at negative 2, negative 2. Okay, so those are our transformed values that have gone 90 degrees clockwise from the origin. Now in number 2, we're going to rotate the figure below 90 degrees, but in a counterclockwise direction. So our coordinate notation for counterclockwise is going to be negative y comma x. Okay, so let's go ahead and write these. So we're going to have negative y comma x, negative y comma x, negative y comma x, and negative y comma x. And we just go ahead and plot those points. So we're going to go transformed p. Let's go get our transformed k, so 0, 3. Transformed n, should be over here. And transformed f down here. And we just connect the points. So number 3 is actually going to be the most helpful problem for this homework and for the 13B homework. When we rotate something 90 degrees clockwise, that's just like problem 1 there, our coordinate notation is y comma negative x. If we go 180 degrees, so a little bit further, it's going to be negative x comma negative y. If we go to 270, yet another little bit further, it's negative y comma positive x. Okay. Now please note that these were all clockwise. Every single one of these was clockwise, and the next two are going to be counterclockwise. Okay, the next two are going to be counterclockwise, and I'm actually going to start with E. Okay, a rotation 270 degrees counterclockwise is y comma negative x, which is the exact same positional location as 90 degrees clockwise. So they have the same coordinate notation. Okay, they're in the exact same position on the coordinate plane, so their coordinate notation is identical. The same exact thing happens with the 180 degrees. So we get negative x comma negative y. Okay. Now, if you have this on a sheet of paper, I would hold this, keep this with you as we turn through the next couple of homework assignments. So number 4 says describe the transformation of the line y equals negative 1/2 x minus 4. So I'm going to go ahead and highlight that line for us. So we're going to describe the transformation from this line that you see to the new image. Okay, we're going to create an equation for that new image, and we're going to talk about that transformation in both words and coordinate notation. So something I want to note on all 3 of these graphs, okay, the coordinate points 0, negative 4. Okay, that y-intercept point. Okay. On the first graph, I want us to note the point 2, negative 3. Let's start there. Okay, so we have 2 points on the original graph, And on the transformation graph, there's a well-defined point at -4, 0, another well-defined point at -3, +2. And by looking at those and comparing the x and the y values here, we have enough to fill in all three pieces below. Okay, so let's look at all three pieces below. I'm going to start with the coordinate notation. The coordinate notation looks like we have y, comma. Do we have y, comma? Yes, it's y, comma, -x. So y, comma, -x. And if you look at y, comma, -x, that's a rotation 90 degrees clockwise. Okay. Now let's get that equation. We have 2 points, so I can find a rise and a run, so that's 2. So y equals 2x, and the y-intercept is 8. Okay. So let's look at the next one here. I have the point 0, -4, and I'm also going to plot the point -2, -3 again. So they're all on the original graph. Okay. So 0, -4 stays, and -2, -3 becomes 2, -3, which again gives us a lot of good information to fill in what's below. What's happening with the coordinates is that looks like -x, comma, y. And if we have -x, comma, y as a throwback for us, that's a reflection over the y-axis. Okay. And we have enough information to find the equation. We can say we have a rise of 1 and a run of 2. So I have 1/2 x minus 4 because of the y-intercept. Okay, let's look at this last one here, and I've got the point 0, -4, but we also, on the transformed graph, have the point 4, 0. Okay, we also, for a little bit of help here, have 0, -8. There's your y-intercept. We can put in one more there if you need it. 1, -7 to help. It's 1, -6 to help with finding slope. Okay, so let's look at this. What's happening here? To me, this looks like it's the y value has changed, and then the x has not. So -y, comma, +x is a rotation 270 degrees clockwise. Okay, and we can get our equation. We can say a rise of 2 and over 1, and our y-intercept of -8. So we've gone through the big bulk of this. We want to rotate the next one 180 degrees around the origin. Oh, you can see I've actually already done this as kind of a practice run through. But what this is 180 degrees is -x, comma, -y. -x, comma, -y. So I'm going to plot all of our points. So h is at 2, -2. I is at 5, -2. J is at 6, -5. And K is at 1, -5. And let's do those transformations. So we're going to have -x, -y. -x, -y. -x, -y. -x, -y. So -2, 2, there's your transformed h. -5, 2, there's your transformed I, transformed j, and transformed k. And underneath it says, what's that coordinate notation? Well, we started with that coordinate notation. Well, what if we're going to rotate the figure 90 degrees clockwise? 90 degrees clockwise. Again, look to problem number 3 if you need it. That's going to be y, comma, -x. Okay, so let's look at the points here. We have B. We have B is going to be, let's see, where is that? It's much nicer when they put the numbers in for us, the grids, but we can count this ourselves. 1, 2, 3, 4, 5, -5. 1, F is going to be at negative 1, 3. H is going to be at negative 1, negative 2. And M is going to be at negative 4, negative 2. So let's look at those transformations. We're going to have y comma negative x. Y comma negative x. Y comma negative x. And y comma negative x. Let's go plot those points. So I've got B is at 1, 5. F is at 3, 1. H is at negative 2, 1. And M is at negative 2, 4. There we go. And our coordinate notation, y comma negative x. Number 7 is now asking us to determine the degree and direction of rotation around the origin. Well, this is going to be as simple as, okay, here is n. Let's look at this point. It's going to be 6, 4. And its transformed point is at negative 4, 6. So what do you see is happening here? Well, we have negative y comma x. Okay, and if you're determining that degree, look at problem number 3. That's 270 degrees clockwise. Okay. We'll do the exact same thing on the next piece of number 7. I'm going to look at E and say that that is negative 6, negative 1. Ooh, it's actually negative 2. And the transformed value is at 6, 2. So what happened here? That looks like negative x comma negative y. And again, refer back to problem number 3. Negative x, negative y is 180 degrees. And you can say clockwise, or you can say counterclockwise. It doesn't matter for 180. Okay. In number 8, we are basically being asked to say, okay, so where are we shifting? Where are we shifting from the origin, the vertex at the origin, to the shifted vertex? Now remember H and K, those are your vertex. Okay? Those values represent the left-right movement and the up-down movement of the vertex. Remember, this bottom piece is our vertex. Okay? So we're shifting to 4, 2. So our equation is x minus 4 plus 2. And I know it feels weird that there's a minus there, even though you're going to the right, but it is the opposite direction of what you expect. It should be a negative there due to a double negative issue in the problem. So, for example, that negative 4 in the problem says we're going to go to the right 4 and up 2. In the next one, here's our origin. The shifted origin, the transformed origin, is at negative 3, negative 2. So our equation is x plus 3 minus 2. So this one's going to say left 3 and down 2. Left 3 and down 2.